Alright guys, the last section for Unit 3 is Section 5.5, which is going to be solving nonlinear inequalities. And guys, I updated the homework assignment and took a few of the problems away. So on page 384, after we watch this video, you'll be able to complete problems 5, 7, 19, 22, 25, 28, 34, 37, 46, and 47. That's an updated assignment. That's a little bit different than and a little bit shorter than what the original assignment was. Ignore the original assignment and just complete this list of problems for this section. So let's just jump straight into it. So we know how to solve linear inequalities, and that's where we would just isolate x. In terms of an inequality, we'd isolate x, move everything to one side, combine variables, and then solve. And then if we end up dividing by a negative, we would flip the inequality. But what if it's a nonlinear inequality? So for example, x plus 3 times x minus 1 squared greater than 0. There's no way to isolate the x to identify the answer to this inequality. So what we're going to do is we're going to solve this inequality using the graph. Okay, so what we're going to do is we're going to come over here and we're going to graph f of x equals x plus 3 x minus 1 squared. Okay, and we did this earlier in this unit. The leading term would be x times x times x, which means the leading term would be x cubed. So we know that the end behavior would look like this, and we know that it has an x-intercept at -3, that it passes straight through, and it has a x-intercept at 1, which is U-shaped. So a rough sketch of this looks something like this. And now, if I come over here and replace x plus 3 x minus 1 squared with f of x, we get f of x is greater than 0. And remember, f of x greater than 0, f of x is just the same thing as y, so that's just saying y is greater than 0. And if we're talking about, here's the x-axis, and this is saying the y values are more than 0. Well, here's our y-axis. Here's where the y values are positive, and then down here the y values are below the x-axis is negative. So y is greater than 0 is just saying, where is this function above the x-axis? And we see that it's above the x-axis, starting at -3, and it's above the x-axis all the way to infinity. So but it's actually right here, it equals, it's at the x-axis at 1, and this is saying we want to just be above the x-axis, not at the x-axis. So this is going to be -3 to 1, and then 1 to infinity. Alright, now let's say we do another inequality. Let's say we have this. X minus 1 over x squared minus 4 is less than or equal to 0. So let's say we're doing a rational inequality. We can't just isolate the x from this. We'll get false information. So what we're going to do is we're going to do the same thing. We're going to draw the graph of f of x equals x minus 1 over x squared minus 4. Alright, and guys, I'm going to run through this kind of quick, but we've already done this problem, or a problem similar to this. We have a vertical asymptote at 2 and -2, because we'd set the bottom equal to 0 and solve. Also, since the degree on top is 1, the degree on bottom is 2, since the top degree is smaller, the horizontal asymptote is at 0. And then if you solve for the x-intercept, you get x-intercept at 1. And then when you solve for the y-intercept ends up being like 1/4. And when you plot additional points, I'm not going to go through the manual process of this, we get this graph here. Okay, So, and then once again, this right here says we're going to replace this with f of x, which is f of x is less than or equal to 0. So this inequality here, x minus 1 over x squared minus 4, can be thought of as f of x is less than or equal to 0, which once again means just the same as y is less than or equal to 0, which less than then means that it's below the x-axis. The equal to 0 means or on the x-axis. Okay, so we see that it's below the x-axis over here, so that would be negative infinity to negative 2. And then we see that it's starting at 1 and going to 2, it's below the x-axis, but specifically at 1, it's also on the axis. And this is asking you for the answers that are below and on. So then that means that if you pick any number between negative infinity and negative 2, or you pick any number between 1 and 2, and you plug it in, you'll get an answer that is negative or 0. Okay, so the solution to this inequality, hold on one second, buddy, is negative infinity to negative 2 union 1 to 2. And if we wanted to just check this, if I plugged in, say, negative 3, negative 3 minus 1, negative 3 squared minus 4, that gives me negative 4 over 5, which is indeed less than or equal to 0, so it checks. If I picked a number between 1 and 2, so let's check, say, 1.5. 1.5 minus 1, 1.5 squared minus 4. That gives me 0.5 over negative 1.75, and we see that that is going to be a negative answer, which is guaranteed to be less than 0. So that checks. If I plug in 1 minus 1 over 1 squared minus 4, we get 0 over negative 3, which is equal to 0. And it says it has to be less than or equal to 0, and that's equal to 0, so that also checks. Okay, so any number that's in either one of these intervals is going to be the answer to this inequality. And maybe I should go back up here in just a second, guys, on this first one. Any number between negative 3 and 1, or between 1 and infinity, is going to be the solution to the inequality x plus 3, x minus 1 squared. Okay, and I'm going to just show you, we didn't include 1. Here's why. If we let x equal 1 up here, this would be 1 plus 3 and 1 minus 1 squared, which is 4 times 0, which is 0. And this is saying we only want the answers that are bigger than 0. So 0 is not bigger than 0, 0 is equal to 0, so this does not check. So 1 gets excluded from the answers, giving us this is a solution set, negative 3 to 1 and 1 to infinity. Alright, now that's how we solve these graphically, but how do we solve nonlinear inequalities? Algebraically, which means we don't want to go to the hassle of knowing how to create all the graphs. So what if we're given a nonlinear inequality and we want to solve it without drawing the graph? Okay, and to do that we use what's called a sign diagram. So and here's the key with this, and we're going to run through the steps, and then when we do it I'll explain this. So step 1 is we have to set the inequality to 0. And both the examples that we did above were set equal to 0. And we'll do one example where it's not set equal to 0, or set, and the inequality is not set to 0. And then step 2 is going to be find and plot all zeros and excluded values on a number line. Find and plot all zeros and excluded values on a number line. And we'll do that here in just a second. But what I'm getting at here is, notice, we're talking about when is it above the x-axis, when is it below the x-axis, or on the x-axis. Okay, that only happens at your x-intercepts, your zeros, or it happens at your vertical asymptotes, which are your excluded values. So the only time the function is going to go from being below to above, or vice versa, is going to be if we have an asymptote where we have a jump in the graph, or it crosses the x-axis at an x-intercept. Okay, so the only time the intervals are going to change are at x-intercepts and excluded values. So rather than drawing the entire graph, we're just going to plot them all on a number line. And then what we're going to do there is we're going to choose a test value within each interval to check the sign of the expression. Okay. Now we're going to run through an example here, and when we run through the example, I'll show you what I mean. So for example, x cubed is greater than x. Let's solve this. Alright, so the first thing is it has to be set to 0. So we're going to minus the x over, and we're going to x cubed minus x is greater than 0. And then we're going to find and plot all the zeros and excluded values on a number line. Well, this doesn't have any excluded values because it's not a rational function, so there's no divisions. Alright, so what I'm going to go ahead and do is I'm going to go ahead and factor this. These have an x in common. So we can factor out an x. And then also, x squared minus 1, well, that's the difference of squares. That would factor to x plus 1, x minus 1. It always factors to the square roots added and the square roots subtracted. So this polynomial expression in factored form is x times x plus 1 times x minus 1. Okay, so the zeros for this would be x equals 0, x equal negative 1, x equal positive 1. If we set all these equal to 0, we get that it has an x-intercept at each of these three locations. So I'm not going to draw the entire graph. I'm going to just draw a number line. So negative 1, 0, and 1. And these are all going to be solid points because these are all x-intercepts. So the graph might be in like an S shape that does this. It might be an S shape that does this. We might have like a parabola, so on and so forth. But we're not going to draw the entire graph. And we could, but we don't need to. Now, this says we want to know when is this going to be greater than 0, which means positive. So we're not interested in it being 0. So our interval, our possible answers are negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity. Okay, and notice I didn't use any brackets, and you might be like, why are we not using brackets? Because this is where it crosses the x-axis, and those aren't excluded values, so don't we usually use brackets with closed dots? We typically do, but this right here says we're not trying to figure out when is it greater than or equal to 0, we just want greater than 0. So we are not interested in the points where it actually hits the x-axis. So now we've plotted and we found the excluded values on number line. We're going to choose a test value within each interval to check the sign of the expression. So between negative infinity and negative 1, we're just going to pick a number, negative 2. And we're going to plug a negative 2 into the expression x cubed minus x. So we're going to plug it in. Well, that gives me negative 8 plus 2, which is negative 6. It does not matter what the 6 is. All that matters is on this interval is negative. So if you pick any number between negative infinity and negative 1, you'll always get a negative answer. Now negative 1 to 0, we're going to plug in, say, negative 1/2. Negative 1/2 cubed minus negative 1/2, that's going to give me 1/8, negative 1/8, plus 1/2, which is going to be negative 1/8 plus 4/8, which is 3/8. And the number is irrelevant. The only thing that matters is that it's positive. And then we're going to pick a test value that's between 0 and 1. So say 1/2. And guys, I'm going to run through this one pretty fast. It's going to give us the exact opposite answer here. 1/2 cubed is 1/2. You're going to be minusing 4/8. Or sorry, 1/2 cubed is 1/8. And then you're going to be minusing 4/8, which makes negative 3/8, which makes it negative. Okay? And then from 1 to infinity, we're going to plug in, say, 2. 2 cubed minus negative 2. That's 8 plus 2, which is 10, which is a positive number. Okay? And so, notice, guys, it goes negative, positive, negative, positive. It doesn't always do that. So you can't just know, oh, the first one's negative, so then it has to alternate for the rest of the function. It doesn't always work that way. But this right here is saying we want to know, when is this function positive, greater than 0. Okay, and that happens right here and right here, from negative 1 to 0 and 1 to infinity. So the solution to this inequality is the interval negative 1 to 0 union 1 to infinity. Okay, and we can actually jump over to Desmos and I can show you this real quick. If I type into Desmos x cubed minus x, and then if I go and so it's going to show you what the graph is, but then if I go one step further and type in greater than 0, type in this entire problem, it actually graphs the shaded region. And if I zoom in, guys, you'll notice here, look, if I type in x equals negative 1, it starts at negative 1. Alright, I'll just show you. It starts at negative 1 and runs from negative 1 to 0, both having dotted lines. And then it starts at 1 and it goes forever to the right, which is from 1 to infinity. Okay, so when is this function positive? It's positive from negative 1 to 0 and from 1 to infinity, which is what we said using the sign diagram. Alright, and then the last example that we're going to do for this video is 3x squared plus 12x plus 9 over x plus 2 squared is less than or equal to 3. Okay. So, first thing we're going to do is we're going to set this to 0. So we're going to minus the 3 over 3x squared plus 12x plus 9 over x plus 2 squared minus 3. I'm going to leave a little space here, guys, because I know where this problem is going. Now, this needs, in order to solve this, to make this problem easier, we need this to be written as one single fraction. And this 3 is technically 3 over 1. And in order to subtract fractions, we need a common denominator. So we're going to times the top and bottom by x plus 2 squared. Okay, so now this is 3x squared plus 12x plus 9 over x plus 2 squared minus, I'm going to come over here to the side, 3x plus 2 squared. That's 3x squared plus 4x plus 4. When we do the Mickey Mouse technique, x times 2, 2 times x, 2 times 2, which then gives us 3x squared plus 12x plus 12. So this fraction turns into 3x squared plus 12x plus 12 over x plus 2 squared. And remember, we don't need to do anything with the denominator of the fraction, because when you're subtracting fractions, it just gets brought along. Okay, so now that these two fractions have a common denominator, we can combine them into one. 3x squared minus 3x squared cancels out. 12x minus 12x cancels out. 9 minus 12 makes negative 3. Okay, so now on this one, this is saying less than or equal to 0. So we want to know, when is it going to be negative or equal to 0. So we've got to find the excluded values. And the excluded values are going to be where your vertical asymptotes are. So you're going to say x plus 2 squared cannot equal 0. Square root. X plus 2 cannot equal 0, which means x cannot equal negative 2. So once again, we're going to come over here to a number line. And at negative 2, we're going to put an open dot, not a closed dot, because it's an excluded value. So that's our excluded value. Then if we need to find the zeros, we're going to set the function equal to 0. We're going to times the x plus 2 squared over. And we get negative 3 equals 0, which has no solution. So what that means is this function has no zeros, no x-intercepts. Alright, so now this says we want the function to be less than or equal to 0. But since it has no x-intercepts, that means the function will never actually equal 0. Okay, so our only intervals are negative infinity to negative 2 and negative 2 to infinity. That's our two possible intervals that could happen. So we're going to pick a test value that's between negative infinity and negative 2. So for example, let's say negative 3. And then we're going to pick a test value between negative 2 and infinity, which is let's say 3. And then we're going to plug them into this expression. Negative 3 over negative 3 plus 2 squared. And that's negative 3 over negative 3 plus 2 is negative 1. Negative 1 squared is 1. Negative 3 divided by negative 1 is negative 3. Key thing is, on this interval, it is negative. And then now, so just because this is negative doesn't mean that this is automatically positive. And this is exactly what's going to happen when we do this. When we plug in 3, we get negative 3 over 25, which at the end of that is negative also. So this question is asking, when is this expression less than or equal to 0? Well, the fact that it doesn't have any x-intercepts means it will never equal 0. So it will only have the option of being less than 0, which means negative. The sign diagram that we've created over here says that we know it's negative from negative infinity to negative 2, and we know it's negative from negative 2 to infinity. Okay, so the solution to this interval is, or this inequality, is negative infinity to negative 2 union negative 2 to infinity. Alright guys, that finishes up chapter 5. Like I said, make sure you pay attention and you just do the modified assignment for section 5.5. Email me questions by, let's say, Thursday at midnight. This is going to be Wednesday morning. Email me Thursday night, by Thursday night. That way Friday I can make a homework video. A video explaining, going over problems on the homework assignments that you need help with. So the homework video will be posted on Friday. And then the exam will be Monday from 10 to noon. Okay, I will email out the exam at 10, or I'll post it on Edulastic once I get it created. And then you will be responsible to download it, answer the questions, and then scan, email me, or send me pictures of your exam back by noon that day. Okay, so get that out to me. Those questions that you need help with in the homework by Thursday night. That way I can make the video on Friday. Feel free, guys, to email me as much as you need. I know we're kind of uncharted waters with this, trying to figure out how to handle this situation. But it's important that you make sure you're dedicating the time to getting the homework done. And also email me as much as you need to get help. because we do not have that face-to-face time in class like we usually do. So anyways, get that to me, and then I will talk to you here in a couple days. Thanks.